Hello, today I will talk about kernel types, monolithic, microkernels, and hybrids. This presentation is in share of Chole Ledesma, Ivan Quiroz, Valerie Rodriguez, and me, Juan Quesada. This is our agenda, microkernels, monolithic, hybrids, and finally, conclusion. Microkernels. Definition. Minimum software that can provide mechanisms needed to implement an operating system, like address space management, threat management, and inter-process communication. Microkernel architecture. You can verify the following in the image. In the blue square, the core system contains only the minimal functionality. The six red squares, the plugin modules are standalone independent components. Microkernel operating system. Most important part for correct implementation, fulfills basic operations, only software executing at the private level. As you can see in the picture, in the blue rectangle is the hardware above basic EPC. The green circles are the application, driver, Unix server, and file server. In the orange rectangle is the application. Advantages. Modularity by deleting the functions of the operating system to independent process. Security by minimizing the size of the kernel, the risk of vulnerabilities in the operating system code is reduced. Flexibility and scalability. The modern designs of the microkernels allows you to easy and remove functionality.
So now I'm going to talk about microkernel disadvantages. The first one is that they increase complexity. Microkernels can be more complex due to the need to manage inter-process communication and coordination. This can make development and maintenance of microkernels more difficult and time-consuming. The second one is that they have greater potential for bugs. The use of message passing in microkernels can lead to a higher potential for bugs and error due to the increased complexity and the need to manage different models and their interactions. The last one is that they have higher cost. Development microkernels can be more expensive due to the need for specialized knowledge and the increased complexity of development and maintenance. This can make microkernels less practical for some applications and systems. Monolithic kernel. This kernel is an operating system software framework that holds all privilege to access input-output devices, memory, hardware interrupts, and the CPU stack. Monolithic kernels tend to be larger than other kernels because they deal with so many aspects of computer processing at the lowest level. Monolithic kernel architecture. In a monolithic kernel, all these components are tightly integrated into a single piece of software running in the kernel mode, which provides a unified interface to the rest of the system. Now I'm going to talk about the monolithic kernel advantages. The first one is efficiency. Because all the operating system services are contained within a single kernel, communication between different components is faster. Then we have the performance. Monolithic kernels often have better performance because they avoid the overhead IPC and content switching between the kernel and user space. Then we have simplicity. A monolithic kernel is generally simpler since all the services are contained within a single codebase, making it easier to debug and maintain. Then we have flexibility. With all the operating systems services in one place, it's easier to modify and add functionality to a monolithic kernel. This is particularly useful for system administrators who need to make changes to the kernel to support specific hardware or software configurations. Then we have wide support. Monolithic kernels are widely used in popular operating systems such as Linux, Unix, and Windows. And as a result, there is a large community of developers and users who can contribute to the development of the kernel. Finally, we have the compatibility. Monolithic kernels are typically better suited for systems that require direct hardware access, such as servers.
Now, I would like to talk to you about the disadvantages of the monolithic kernel. As it was mentioned before, in the monolithic kernel, the entire system is working in the kernel space, and there is a tight integration of the system services. And for this reason, there are two main disadvantages of the monolithic kernel. The first one, if any service fails in the monolithic kernel, it leads to the failure of the entire systems. And the last one, the entire operating system needs to be modified by the user to add a new service. Now I'm going to talk about hybrid kernel. Hybrid kernel is a kernel architecture based on a combination of microkernel and monolithic kernel used in operating systems. This kernel approach combines the speed and simpler design of monolithic kernel with the modularity and execution safety of microkernel. The idea behind a hybrid kernel is to have a kernel structure similar to that of a microkernel, but to implement that structure in the manner of a monolithic kernel. A hybrid kernel runs some services in the kernel space to reduce the performance overhead of a traditional microkernel while still running kernel code as servers in the user space. For instance, a hybrid kernel design might keep the virtual file systems and bus controllers inside the kernel, and the file systems, drivers, and storage drivers as user mode programs outside the kernel mode. So this design keeps the performance and design principles of the monolithic kernel. Finally, about hybrid kernels, it's important to mention the advantages and the disadvantages. As I mentioned before, hybrid kernel combines approaches of microkernel and monolithic kernel, so it shares advantages and disadvantages. And the main disadvantages of this hybrid kernel is that despite the hybrid kernel classifies as a new type of kernel, it is still working as a monolithic kernel, so it shares mostly the advantages and the disadvantages of this type of kernel.
Now I'm gonna talk about some differences that there are between the microkernel and the monolithic kernel. First, we have the address space. In microkernel, user services and kernel services are kept in separate address space. Instead, in monolithic kernel, both user services are kept in the same address space. In the parameter of design and implementation, the OS is complex to design in microkernel. In size, microkernel are smaller in size than monolithic. In functionality, it's easier to add new functionalities in microkernel. In coding, to design a microkernel, more code is required when it is compared to microkernel. In failure, we find that failure of one of the component doesn't affect the work of microkernel in the microkernel, but in monolithic kernel leads to the failure of the entire system. To conclude, we can add that microkernel provides a set of primitives or minimal system calls to implement basic services, such as address spaces, inter-process communication, and basic scheduling. Monolithic, it is solely responsible for memory and process management, communication between processes, and provides driver and hardware support functions. Hybrid. Typically, it is a microkernel that has some non-essential code in kernel space, so that it runs faster than it would if it were in user space. And monolithic operating systems offer better performance than microkernels, but microkernels are more reliable, since a programming bug in the kernel leads to the mess with the execution of the system.